Okay, we're going to do a little introduction and a review for fitting functions to data. We're going to talk this year about linear, exponential, quadratic, and power functions, and we're doing this using the TINspire CX. So have your calculator with you. Stop me at any time as you're going through the keystrokes to make sure you understand it, and play and replay this to make sure that you understand all the steps that you have to do. Here's the calculator keystrokes. Please refer to these notes as we go through here. You can go through step by step, and we're going to use linear regressions this year, quadratic, power, and exponential. So I'll go through all those when we go through the calculator. And of course we're using the statistics button when we're doing this, and we're using lists and spreadsheets because you're putting in your data in columns. And then we're going to look at your actual scatter plot, and this calculator is so cool because it'll move and you can see it moving your points as you go along, and you can hover around it, and it's very cool. So I really like how this calculator does this, so you'll enjoy that part. I do want to give you a little background of how regression works. We assume that the value of an x is related to the value of y. We assume we can pick the value of x, but that the value of y can only be partially determined. Scientists use this a lot when they get all this data and they try to figure out is there a relationship between these two quantities. And how they can tell if it's a good relationship, if they find a pattern, is they look at the correlation between the two. And this is important. It's called correlation coefficient, or your R value. Okay? And how this works is that your number will lie between -1 and +1 and measures how well the regression line fits the data. If you get R equals 1, the data lies exactly on the line of positive slope. So that's a perfect fit. And if you had -1, the data lies exactly on a line of negative slope. So these two, if you get a 1 or a -1, it's an exact perfect fit. That means the pattern you found works perfectly with that. If your R is close to 0, the data may be completely scattered, or there may be a nonlinear relationship between the variables, and we will be doing other things besides linear, so we could try something else to see if that R value would be, the correlation coefficient would be better for something else. Or the data could be incorrect. In this course we're just practicing how can we look at the best fit. Now I do want to go through the difference between relation, correlation, and causation. It's important to understand that a high correlation between any two quantities does not imply causation, meaning that I can pick two quantities and put them together and see if I can find a pattern, but they might not have anything to do with each other. For example, here's one. There's a high correlation between children's reading level and the shoe size. So basically this is saying if the children's reading level is going up as their shoe size goes up, which, okay, that makes sense. I mean, but does that mean if someone has large feet that they can read better than someone else? Well, no. Or it can mean that the child is growing. Large feet does not cause a child to read better, or vice versa. Notice that the correlation of 0 does not imply there is no relationship. It usually implies that no linear relationship between x and y, but it could be something else, or it could mean no relationship at all. The other two words we're going to see during this is interpolation and extrapolation. Interpolation is you're looking within the data to find an answer, and you're making your best guesstimate. Extrapolation, you're looking outside the data. So, interpolation, reasonable estimate between two values. Extrapolation, estimate outside the values. So for example, if I was given some data here, here's x and y, and my data is this, okay, and I said, could you please tell me what do you think will happen in between 7 and 20, like 10? What you're doing is interpolating. You're making a reasonable estimate between these values after you found the pattern. Extrapolation would be, well, what happens when it's 25? That's outside the data that you had collected, and so you're making a reasonable guess or an estimate outside the values. So interpolation and extrapolation are good terms because we'll use that as we figure out what we're going to do. Okay, now I'm just going to go through one example to show you how to put your data in. So let's get a calculator up here. And what I would suggest that you do is make sure that you have a new document here, that there's nothing open, because sometimes when you do it twice or use the same variables, it gives wrong information, or it'll tell you that there's something that's not working right. So the first thing we're going to do is go to this green icon, and this looks like a little table, and you're going to put in your data. So we're going to call this one, we'll say C. You can call it anything you want to call it. So you always label up here what your columns are. You skip this blue area because this actually you can put formulas in. We don't need to. Then you put the data down here in the white part. So I'm going to put some data here. Oops, this one we're going to call D. Okay, I just made up some numbers here, and we're going to do something with this. So here we are. Once you put your data in, okay, next thing we're going to do is go to your menu, go to Statistics, go to Stat Calculations, and you pick which one we're going to use. Again, I told you we're going to use either 3, a quadratic is 6, 9 is a power, or A is exponential. So the first thing we're going to use, please use the 3, not the 4, but we're going to do linear. And when you put it here, this screen's going to come up. You have to tell what you put in your X and Y list. So we had a C in for X. Tab down and arrow over and put a D here. And then it tells you where to save your regression equation to F1 and your frequency list and all this type of thing. All you got to do now is click OK. And if you'll see, it puts it right here next to your data. And the only thing I don't like is it says mx plus b, but if you're doing an equation, you really have to say y equals mx plus b. And then it tells you the slope, m, and then the b is -2. So if I asked you for the equation, you would actually put the 4 in the m spot and the -2 in the b spot. So you'd say y equals 4x minus 2. You're going to skip the r squared, and we're going to look at r. There's your correlation coefficient. If you'll notice, these columns are shorter, are narrower, excuse me. So this is what you'll see, but if you look down here, you'll see the whole thing. You have to highlight it. So if they want you to actually round it to out more than what you have here, you have to actually click on it and look at it. So now we have our regression equation. Now we want to look at it. So what you can do is you can go home, and we're going to now go to this purple box right here, and we're going to look at it, and you'll see there's all our points that we put on. Now this is what makes this calculator really cool. Take your mouse and come down on top here and click on the bottom here and say, okay, what did you use for next? Well, we used a C. Oh, gotta love it. Now I want to come up here, you highlight over here, click and say what I use for Y, I use D. And look what it does. It's beautiful. So you can look at it, you can add, you can look at your line to see how it, but I can tell that it's curving a little bit. That's why when we were over here it says 0.95. It's close to 1, but it's not perfect. And now I see why is because it doesn't, it curves a little bit. Okay. Now, say I look at this and say I want to see if there's another better fit. So I'm going to hit menu again, do statistics again, and let's try something else that we think might work better. So I do stat calculations. Let's try exponential regression in this one. Okay, now it's going to do the X list again, so I'm going to use C and D again because that's the same data. Now see how it saves it in the F2 area? You click OK. So I'm wondering why I did that. Because it's going in that area. Maybe because I used C and D again. So it should show it again. But right now, I guess what we'll do is we'll leave it at here, and then but usually you can go and see. Let's try that again. Statistics, stat calculations. Let's try this one. Let's try a quadratic regression. The X list was C, the Y list was D, and we're going to save it in F2. Looks good to me. Click OK. Oh, there we go. That's why it didn't work for that. And if you look at it, it tells you here ax squared plus bx plus c. You have to click on it to see. And it tells you a is 1 and it looks like b is 0. And so that basically I'd put a 1 here, so y equals x squared. And look at the correlation coefficient. This one has an r squared, and see how it's 1? It's perfect. So this must be a quadratic, and I kind of did it that way so you could see. And if you want here, you could actually put your equation right in there. So I'm trying to find where that would be. So we put the regression. We'll show the quadratic and see how it fits perfect. That's why it's a 1. So you can try all different kinds to see which one is fit. The exponential was outside of the data range, so it wouldn't work because I touched 0, 0. And we can try other ones, but this one's an actual perfect fit. So there's a little bit of an introduction on how to do regressions. Please hang on to your paper and make sure that you do your notes.